So welcome to the client track, and we're going to start off with Windows Server. So if you want to throw things at me, by all means, go ahead. But I want to dive into kind of what's cool about Windows Server 2016. And I was actually just talking to Kevin Holman, and it's interesting as technologists, we always tend to, we get the new version of the software, we upgrade to that new version, but we don't change the way we do things. Hey, I upgraded from 2000, 2003, 2008, but I'm still doing stuff the same way I did it in 2000. We don't evaluate what's new, we don't evaluate what new capabilities there are and take advantage of them. So my goal for this session is to look at what are some of the cool stuff, what's big and exciting in Windows Server 2016. Now, originally I thought I had 75 minutes, so I did a top 10. If I'd known it was 50 minutes, I would have done a top 3.5. So I'm going to skip the who I am, I've done stuff, and dive into what's the cool stuff, what's new, what's changing. And the first thing, configuration levels. So who knows what configuration levels are? Who's using them today? Not many. Okay, so you've probably heard of Server Core. Server Core was this new thing they introduced in sort of Windows 2008. It was a different way of installing Windows Server. The idea was that, hey, we don't need a GUI. I don't need Internet Explorer. I don't even need Explorer or the MMC. I want a scaled-down version of the operating system. So in 2008, when I installed the operating system, I could pick this Server Core option. So it was less reboots, less patching, so less attack surface. And that evolved, that improved. In Windows Server 2012, I could move between having the GUI, not having the GUI, having the management tools. In 2016, they're making a big change. So Server Core is small, but it's still by and large normal Windows Server. They just skimmed a few bits off. 2016 is introducing a new configuration level, Nano Server. And this is a complete refactoring of the operating system. So what we're going to see in Windows Server 2016 is really 3 different ways of running Windows Server. There's going to be Windows Server with desktop experience. So I have the GUI, I have that desktop experience. I'm going to use this for session hosts, remote desktop session hosts. That's where I want to use the one with the GUI. For other workloads, I'm going to be using Server Core. That doesn't have a GUI. There's no Explorer, there's no Internet Explorer. It's just a real scaled-down version of the operating system. Less patches, less reboots. And then for these built-in-the-cloud applications, for these hypervisors, for scan-out file servers, I'm going to use Nano Server. And what Nano Server is, it is the smallest ever footprint of Windows Server. So it's a 93% smaller VHD size. 92% fewer critical bulletins would apply to it. 80% less reboots. And it's really focused on 2 key scenarios. These born in the cloud, these new applications, and the cloud platform itself. Think Hyper-V servers, think these scale-out file servers. Now what's interesting about Nano Server, who's installed Windows Server 2016? Okay, so a few. There was no Nano Server option. There was no option, hey, I want to install Nano Server. So where is this thing? It's actually sitting on a folder on the Windows Server media. So if you actually, I'll just bring up a sort of session over here, and if I scroll around and jump to my server, if you go and look on the media, you'll actually see sort of a Nano Server folder. And so what you do is to build and deploy a Nano Server, I build a new Nano Server image. By default, Nano Server has nothing in it. It's the core kernel, the core part of the OS, but there's no Hyper-V, there's no file server, there's no IIS, there's nothing in that image. It's completely bare bones, which is why there's no install option just to offer the menu. It will be useless to you. So what I have to do is I have to go and create a new image I want. So if I just run this piece of code here, this piece of code right here will go and create a new Nano Server image. So it's copying some files around. And if you look at the code, I don't know if you can see it well, but basically I specify a path where I've got that Nano Server source material off of the Windows Server 2016 media. And then I specify a few flags. I say I want guest drivers. I'm going to run this as a VM. So I need to add those into that image because they're not there by default. I'm going to say I want storage. Maybe I want to run a file server off of this thing. I want Windows Defender. That's now a core part of Windows Server 2016. I want compute. Hey, I'm going to run this as a Hyper-V server. I'm going to enable remote management so I can manage it from remote subnets. I set a password. I set the domain I want it to belong to. And I say, hey, there's an existing object. Reuse it. That's it. And what this is doing is bringing all these things together and creating me a VHD file. This is creating a nano server. And so it's now just wrapping all that stuff together. I want to show just how quick this thing is, because this is actually just building a brand new nano server image. And what it's doing is actually creating a VHD file. So if I scroll over to the folder, what it's building is this nano server VM. And you see its size is tiny right now. And what it's adding into it are these additional components. Those flags that I've specified, it's adding in the language packs, because the binaries are language neutral initially. So it's bringing in the components, the languages, and adding it all into that VHD file. And that's how I build a nano server. Now, your goal in Windows Server 2016 is if you can use nano server, you're going to want to use that. That is going to be for your Hyper-V servers, for your scale-out file servers. Think Azure Stack. Azure long-term, it'll be based on nano server, this tiny, tiny footprint. And there's a huge shift, and that's finished. We're used to loving our servers. We name them. We heal them if they're feeling sad. We'll spend a lot of hours fixing those things. The new mentality is they're not pets, they're cattle. If it's sick, we shoot it in the head, and we build a new one. That's the new mentality we're moving to. Nano server is basically headless. So what I'm going to do now is that VHD I just built, I'm going to run another tiny bit of code. Now, all this tiny bit of code does is mount the VHD, and it updates its unattended answer file to put in a time zone. So I'm going to change it to Central Standard Time instead of Pacific. So now I have a VHD. I'm going to take that VHD file I just created. So this is a brand new image, never been used before. I'm going to take that image it just created and look at the size of it. So it's nearly 700 megs. That's because I added quite a lot of different features to it. I'm going to go and move that into this new folder for a virtual machine. So I'm just copying that over. Then I'm going to add that disk to a virtual machine. So I have one sitting here waiting patiently. It's actually really hard for me to read. Does that say Nano Server 2? No, that's 1. Hold on. There we go. That's better. So I'm going to edit this, and I'm going to use that VHD file. So I go to my IDE controller, add in that brand new hard drive I just added, browse, and in the folder, there we go. OK. And I'm going to turn that thing on. So remember, this is a brand new machine. It's never booted before. It's got to go through the specialized, the first one I've ever powered up an OS. Now, normally, if I turned on a brand new OS, how long would that take to be usable? 8, 10 minutes, a kind of a best case scenario. So here we go. I'll power it on. So it's starting up. There's the OS going. This is now running through that full configuration, and it's done. That's Nano Server. That's not just boot speed, that's boot and the initial setup of the entire operating system. And it joined the domain. So if I now log on, that's it. That's Nano Server. I mean, if you think that's kind of crazy. So think now the world of hyperscale, how quickly I want to add things, remove things. If it's sick, I'm not going to bother fixing anything. I can create a new one in 2 seconds. This is the future. This is in 2016, more and more things can be built on this Nano Server environment. Now, I do not do anything locally. This is as powerful as the local interface gets. I can't run PowerShell. I can't run command prompts. I have a very, very basic console that in a worst case, I can fix networking. I can set a static IP address. That's it. All my management is done remotely. Yes, I can use Server Manager. Yes, I can use PowerShell. I can use WS management. But locally, this was even added at last minute. This wasn't going to be there originally. Everything is done remotely. It's headless. So this is huge. I mean, this is going to be the sort of future. This is where everything is heading from a fabric perspective. I'm going to be using Nano Server. So that's my number one. That's my first thing I can think of. Next, containers. Who's heard of containers? A few? So again, this is huge in the Linux world today. If you've not heard of containers, you might have heard of Docker. There's this big push right now for the ability to containerize bits of code, middlewares, applications, even the operating system. And the reason we have that is really a challenge today for people writing apps and then trying to deploy that application. Many of us may have, in the server management world, the application developer writes some piece of code and he gives it to you and says, hey, deploy this to production. And you try and run it on the server, it doesn't work. Hey, this doesn't work. Yeah, it does. No, it doesn't work. The developer gets on the box, installs a bunch of junk on your production server, and now the thing works. It's a challenge. I don't know what the dependencies were. So what containers enable me to do is I can compartmentalize each component, the middleware part, the application part. I can say, hey, there's dependencies between this app and this particular middleware, this runtime. And I can then pull those down from a library and then easily deploy it to a service. It's a very consistent way to deploy things. If you knew AppV, you're the client guys, you probably know about AppV virtualizing the app. Still runs on the OS, but it's all virtual file system, virtual registry. It's similar. It's different, but it's similar in concept to that. I'm now creating these containers that isolate it from other things running on that box. And so what this ends up looking like is here. I have apps that have dependencies on binaries and libraries that have dependencies on a host operating system. So I can now run multiple apps on a single operating system instance. So it's different from virtualization. It's not one VM per app. I'm now sharing an operating system. They share a common kernel. So all these different applications, they're isolated in the user mode space, but they're running under the same kernel. Some of them use the same sets of binaries and libraries. Some of them have their own sets they want to use. They all have their own dependencies. They're completely abstracted as I want them to at the user level. But that can be concerning, that kernel thing. Hey, they're sharing a kernel mode space. If this is on premises, if this is in my data center, I'm probably okay with sharing a kernel mode space. I trust the apps. I'm the admin of all of these. I don't mind. If this is out in a public cloud somewhere, do you likely want to have your app sharing a kernel with some other tenant's app? Could be some bad person doing bad things. I don't want that. So Windows Server is introducing containers. And what it's introducing is two different ways to deploy the container. So you're going to have Windows Server containers, and you're going to have Hyper-V containers. The container itself is exactly the same. I create the container exactly the same way. It's a deployment choice. When I deploy that container, I decide, hey, what level of isolation do I need? If it's in a trusted environment, then I might just deploy a Windows container. It's running with other containerized applications on a shared kernel. If maybe it's more critical, if it's in a multi-tenant environment and I don't particularly trust those other containers, I'll deploy it as a Hyper-V container. And behind the scenes, automatically, Windows Server is going to spin up a mini kind of virtual machine with its own kernel and run that container on top of that virtual machine. So it's the same container, it's just, hey, if I want the absolute highest level of isolation, I'm going to stick it in an automated VM for you. Now, you've probably heard of Docker. Docker is not a container. Docker is kind of a management, it's a repository. We're going to support that. So in Windows Server 2016, Windows containers will work with Docker. So I can use the Docker libraries, the Docker command line tools, or I can use PowerShell. So you're going to have a choice. It's completely up to your organization. If you're invested in Docker today, fantastic. Take that investment and carry it on into the Windows world. If I'm not a Docker shop today, and I'm really, hey, I love PowerShell, I'm used to this, then I can manage this all through PowerShell. Storage. Normally we don't get too excited about storage. In fact, maybe you never get excited about storage. But there were huge shifts in storage in Windows Server 2016. We started to see some of it in the previous version in 2012 and 2012 R2. And it's really this move to this new hyper-converged type model. Many of us are used to the idea that I have my servers, I have my storage, very discrete units. I have these very powerful SANs. It's moving more and more into this world now where the servers have their own storage. Storage space is introduced in Windows Server 2012. Let me take local disks to a machine or disks in an enclosure, and I could do cool things. I could do thin provisioning. I had different levels of kind of parity, of mirroring, resiliency. 2012 R2 let me actually use a clustered storage space. I could use an external enclosure across multiple nodes. 2016 takes it to the full, I think, potential of this. So what are these? So storage spaces direct and storage replica. Now there's a key point here, and this is maybe different from what we're used to. These features are part of the data center SKU only. So there's a difference here. We're used to Windows Server 2012, standard and data center are the same. They have the same features. The only difference is virtual machine rights. That is changing in 2016. So in 2016, there are now features that will only be in the data center SKU. So there is a shift there. So these two storage features I'm going to talk about, hey, these are part of the data center SKU. There are other things as well. There's consolidated storage quality of service, better deduplication support, ReFS. You're going to see it everywhere. But I want to focus on these two features in particular. So what Storage Spaces Direct is going to do, I have machines in a cluster, and they have local disks. So I have 4 nodes. Each of those nodes has 2, 3 data disks. I can now aggregate them all together. So think kind of like a vSAN. It's going to take the discrete storage of each server, aggregate it up together, so I'm now going to see a consolidated cluster shared volumes, clustered storage through those local disks. So this is a huge change. It's actually going to create a storage pool. It's going to use storage spaces technology. It's replicating using SMB, so familiar protocols we're used to. If I have hard disk drives and I have SSDs, it's going to take advantage of those. It's going to use the SSDs for those hot blocks, the ones that I'm accessing the most, and then hard disk drives for the bulk storage. I'm going to format it with ReFS. I can run my Hyper-V VMs off this. I can use it as a scale-out file server to offer remote storage to other servers. And I'm going to have this resiliency across nodes. I can think of each node as a fault domain. Hey, something could go bad with that node. So what Storage Spaces Direct is going to do is going to replicate the data to make sure it's always on 3 fault domains. So I have the data on node 1. There's also going to be a copy on node 2 and node 4, for example. So I'm never at risk of losing my data. So it's actually mirroring the data across those nodes as well. And I'm going to try and demonstrate this. So just give you an idea of kind of what it does. So this is obviously Windows Server 2016. And what I created was a bunch of virtual machines. It's kind of, apologies, I look like I'm drunk. I'm not drunk most of the time. So I have 4 nodes, they're all running in 2016. And what I did is I added 2 data disks to each of those virtual machines. And I'm going to use PowerShell to actually demonstrate this. Let me just get my mouse up there. There we go. And the first thing I'm going to do, so it is all PowerShell. Hopefully you can see most of that. So the first bit of PowerShell just lists what disks are available. And when I run that, you can see I have 8 disks available. So there's 2 on each box. So I have 2 10 gig data drives on each box in this cluster. So the next pieces of code is basically just going to go and create that storage pool. So if I scroll down, you can see I'm going to create a new storage pool using all of that available storage. So I'm going to go ahead and create the storage pool. So that's now taking all that aggregated storage across all 4 of those nodes, and it's going to surface it as a single cluster shared volume. It's now all in a single pool. So it went ahead and it created that. And now, basically what the rest of this code does is create a volume on it. So I'm just going to run all of this code. There we go. Make sure I get it all. This is a really bizarre experience. Okay, I'll run it one at a time. Okay. So on the first one, this is going to go ahead and create the volume. And I'm just going to set file integrity on it. And at that point, I should see a cluster shared volume actually on my system. So let that finish. And if I open up Explorer, what I should now see on my machine is just a regular under cluster storage, volume 1. So that's using all of those 8 disks across all 4 nodes. It's now aggregated it together as a single volume that I can use. So let's kind of prove that though. I'm English, we're not the most trusted society in the world. I could be making that up. So I'm going to set the file integrity. And what I'm now going to do is, there's a test utility. And I'm basically going to run this disk performance util. And it's just going to hammer that new cluster shared volume I just created with a test file. And so if I run that command, and I open up Performance Manager, you can see this is the performance, the I/O on each disk. So I can see across the 4 nodes, every disk is getting hit. Because I'm basically just read-writing to that cluster shared volume, which actually exists across all 4 nodes at the same time. Every write that occurs, it makes sure it synchronously writes to 2 other servers as well. So there's no risk of me losing my data. So this is a huge feature. If you think about, hey, maybe my branch offices, maybe even my core data centers, and I'm looking at a new world where I have these hyper-converged servers, where I have local storage, how can I utilize that? I can utilize it for my Hyper-V virtual machines. I could build a scale-out file server and have other services use that storage remotely. This is now just a core part of the operating system. Yeah. So another storage thing, so that's cool. Another one, storage replica. So storage replica is a block-level replication between standalone boxes, between nodes in a cluster, between clusters. So now, because it's block level, I don't care about what's going on above it. I could be using deduplication, I could be using BitLocker, I don't care. This is block level. Anything could be going on above those blocks. Does not matter to this workload. I can run it in a synchronous or an asynchronous mode. So synchronous would be, hey, I'm within a location. So obviously synchronous, it has to happen on both sides before it gets committed. So I can do a synchronous replication. If it's maybe between locations, I would use asynchronous. Synchronous is the preferred, synchronous is the default, but I can absolutely use asynchronous if I want to. So now any workload at all, I can replicate. Again, within my data center, hey, I'll do it synchronously. Between locations, okay, I'll use asynchronous for that. So I have these fantastic new scenarios that I can now handle just with kind of the inbox storage of Windows Server 2016. So distributed file system replication has been around, wow, is that 2003 R2 introduced DFSR? So DFSR is a file level replication. And DFSR only replicates when the file is closed. So with DFSR, I could never replicate an in-use file. So think about Hyper-V virtual machine, for example. That VHD file would never replicate while that virtual machine is up and running. And I should repeat, sorry, the question was, how does this differ from DFSR? So DFSR is a file level. It used some very cool stuff in terms of compressing it, but it only worked on closed files. So the challenge here is that it wouldn't work with certain features of the file system as well. This storage replica will work with anything because it's block level. So I don't care if a file's locked. If the block changes, I'm going to replicate that thing. So databases, I could replicate with this thing. VMs, I could replicate with this technology, which maybe gives you some idea of why it's part of the data center SKU. This is very much a data center driven feature. So I can really replicate anything now. Cool. Great question. Networking. Who's using network virtualization? Just a quick show of hands. No one. One person. Good job, you. So network virtualization is this fantastic technology, but I think it's getting a little bit of challenge really getting mainstream support. People are used to VLANs. People understand VLANs. I think the idea of network virtualization can be intimidating. From the Hyper-V side, we leverage SCVMM. And I'm an SCVMM guy. I understand SCVMM. Networking SCVMM scares the hell out of me. It can be fairly intimidating. I have to get a good branch on that to really understand it. In Hyper-V, we use NVGRE as kind of our supportive way to do network virtualization. In 2016, we really are working very hard to make it better, to make it more supportable across the industry. So NVGRE is what we used in Hyper-V. In 2016, it now also supports more standards, VXLAN. So VXLAN network virtualization will be supported in Windows Server 2016. I have a choice in how I actually want to enable that. I don't have to use SCVMM anymore. Now, it's still preferred. That's going to be the best experience in terms of manageability. But there's this totally new component, network controller. This kind of comes from the Azure fabric. Again, we're seeing the huge sort of advances in innovation Microsoft does in Azure coming to some of our on-premises functionality. So network controller, that's going to enable me things like load balancing, great ways to interface with other networking devices. That's going to be sort of the fundamental part of network virtualization now. So it's going to be much easier for me to deploy. It's going to be far more compatible with other things I'm doing in my environment. So no one's really using it today. Is that just you love VLANs? Is VLANs number one? Never would get rid of VLANs? Or is it, hands up if it's network virtualization seems intimidating? A couple. It's a few brave people. Everyone else says, no, I'm not intimidated by anything. I'm American. Very brave. It is intimidating. I'll be very honest. The switch from sort of VLANs to use network virtualization is a pretty big shift. But if you want to try and get out of the world of, hey, I need to do a new VLAN, I need to upgrade this switch, and hey, where do I have VLANs available? Network virtualization makes it a pure software-defined play. So I think the direction will go there eventually. It's just kind of we need to get past sort of that. We love our VLANs, we hug them, they're our pets. We need to get past that, and there's really a lot of technology in 2016 that's going to make that easier to do. Clustering. Everyone loves clustering. One of the favorite features of nearly everyone is clustering. I get people talk to me and say, we hate clustering. Clustering is the devil. And that's generally based on experiences with Windows 2000, Windows 2003. Anyone ever create a cluster on Windows 2000 or Windows 2003? Some people. It was hideous. It would be like this 50 dialogue thing. It would ask for your DNA and firstborn. It worked, but the setup was horrible. Trying to fix it was horrible. 2008 totally changed that. A couple of clicks of a dialog box and I have my cluster. It made all the decisions for you. But what kind of we've noticed is that clusters today are maybe not quite as resilient as people used to create them. In the early days of clustering, I would have special hardware, I'd have dedicated teams, I'd be very careful about my networking and my storage. They were resilient. These were very sturdy systems. Today, anyone just says, oh, I'll throw these 3 boxes together and I'll jam a cable in, there's my cluster. Now go and run all my production workloads on it. And what happens is you get these transient failures. Maybe it's a transient network failure. So a node can't talk to the other nodes for a second. That's all it is. It's a blip. The challenge is clustering says, hey, look, there's a blip. I better drop everything from this node and move it to other nodes. So a 1-second transient problem results in 7-8 minutes of downtime just because there was a blip in the network. Maybe there was a blip in the storage connectivity because, hey, I've not architected my network or storage that fantastically. So these blips happen, and they're highly disruptive. So what's happened is 2016 is taking huge steps to kind of protect you from your non-optimal, I can't say crappy, people don't like that, from your non-optimal cluster architectures you've done. So it tries to work with that. Domain boundaries are gone. So a cluster used to have to exist within a domain. It doesn't anymore. I can have nodes in separate domains. I can have nodes in work groups. It's now all certificate-based. Now I say certificates, and you're like, oh no, certificates. I'm not going to use clustering anymore. It's all automatic. They're all self-signed certificates. All I need is a credential that has administrative rights on the nodes. Everything is done for me. I don't have to set up a PKI. I don't have to do anything like that. It's just using it internally to handle authentication because I now may not be part of the same domain. So I have to have another way to do that authentication. So I can now bridge these domains. It's easier to get to 2016. I can actually mix versions in a cluster now. So I could never do it like a rolling upgrade. I could never mix 2012 and 2012 R2 nodes in the same cluster. I can in 2016. I can have a 2012 R2 cluster. I can pull a node out. I can install 2016 on it and put it back into that cluster. So now I have a cluster with a mix of 2012 R2 and 2016. I pull another node out. I put 2016 on that. I put it back in the cluster. So I run in this mixed mode. Once I've upgraded all my nodes to 2016, I flip a switch. I go into kind of native 2016 cluster level, and I can take advantage of the new cool stuff in 2016. So this is huge in terms of thinking about how can I get to 2016. Clustering's always been kind of a barrier in terms of the upgrade before because I had to create a second cluster. I had to migrate resources between them. It was very, very painful. That's gone. And I have a very easy way to get from 2012 R2 to 2016. This is not going to work from 2012. This is from 2012 R2 to 2016. The cloud, as you would expect, is fully embraced. I can now use an Azure storage account as the witness resource for my cluster. So clusters have a witness resource. It used to only be a disk, so it was some shared disk they could all access. In times of arbitration, one would grab that disk and say, hey, I've got this disk, I keep quorum, I keep running. Because of Exchange and having maybe distributed workloads, file shares were added. So there wasn't any shared storage anymore, so I could use a file share. The challenges come as we get into these multi-location clusters, these geo-clusters, where I don't have a third site. If I have two locations, then having the quorum resource at either one of them breaks the whole point. There's no point of arbitration anymore. I can now use Azure. I can actually, when I create my cluster, I can say, hey, look, I want to use an Azure storage account for my quorum. So if I just quickly jump over, so on this box here, if I jump to one of my nodes, I'm actually running this using Azure. So if I look at my cluster, if I look at my configuration, it's hard to see, but you'll notice the witness is a cloud witness. So this is using an Azure storage account actually as the witness resource. Now, we never like to use the word free. This is kind of as free as it's going to get. So this is my storage account in Azure. And what I'm going to focus on is what it does. So if I look at my blobs, it creates a Microsoft Cloud Witness folder. If I look inside to see what it creates a 0-byte file. Azure kind of rounds, I think it's down to the penny, so 0. Now, I'm not saying you'll never get charged anything, but if you do, it's going to be a cent. So basically now I can use Azure resources at the witness for my cluster. So if I have a cluster split over multiple locations, I don't have a third location for the quorum, hey, I can just use Azure now. Very, very simple to do. I give it a storage account name and the key, and I'm done. So great if you have those multi-location. Great if I have clusters in Azure. If I don't have a file share witness in Azure, if I don't have a shared disk, I can actually use an Azure storage account in any of the Azure regions. Okay. But this is not the cool stuff. Compute and storage resiliency. Basically the idea that clustering has to be careful. And there's kind of a seesaw here. And the way the seesaw has been today is that any blip in communication between nodes in the cluster, that node would fall out of the cluster. It would lose quorum. Any services running on that node would move to other nodes, which is why this 1 second transient problem, if I had 20 VMs running on that node, all 20 VMs would just be effectively shut down and restarted on other nodes. That's a pain point. What we now have is resiliency. So the resiliency will now actually say, look, if it can't talk to the other node, I'm going to let the VMs run for a little bit. I'm not going to fall them over straight away because it might be a transient problem. So now I'm going to let you run for a couple of minutes. Now if after a couple of minutes you're still not part of the cluster, then I'm going to move the VMs over. But now those transient problems between nodes, the VM will not shut down. The VM will just keep running. Even though the node has fallen out of the cluster, it will not stop that VM running. It will keep running. What about a storage problem, a blip in the storage connectivity? This is the biggest problem with clusters. It's nothing to do with the cluster, it's the storage config. The HBAs, there's some issue with the storage path between the node and the storage. So in 2016, if it loses access to the storage, you know it's just going to stun the VM, it's going to pause it. And then as soon as the storage comes back, it will unstun it. It will just bring it back again. So I'm going to try and demo this. So let me jump over again to my servers. So what I have here, I have a 3-node 2016 cluster. And again, apologies for if it's not the clearest in the world, but hopefully you can see I have 3 nodes. Node 1, 2, 3, they're all up. I have 4 VMs, VM 1, 2, 3, 4, and then I have Hyper-V Manager running on my 3rd node. Just shift that down for a second. Now, what's important is VM3 is running on a cluster shared volume. VM4, I'm running on a file share, an SMB3 file share. So what I'm going to expect to happen is if I pull node 3 out of the cluster, VM3 should just stun. It should go into a pause state because it's lost its storage. Cluster shared volume cannot continue outside the cluster. So VM3 should just pause. VM4, because it's running on a file share it can still get to, should carry on running. Even though this node is going to fall out of the cluster, that VM should carry on running. Now, to emulate it falling out of the cluster, I'm just going to stop the cluster service. Boys and girls, don't do this at home, but end task. Yep. So what we'll see is the node is now isolated. This is a special mode. The VMs have gone unmonitored. VM4 is running along quite happily. VM3 is running critical and is going to just pause in a second. There you go, pause critical. So this is showing storage resiliency and compute resiliency. So VM4, even though the node is now isolated, it's not part of the cluster, that VM is still running. Can still get to the storage, it's keeping it running. VM3, I can't get to the storage anymore, but rather than it crashing, rather than trying to fail it over, do you know, maybe it's going to come back. So rather than take 6-7 minutes of downtime to shut down the VM and move the VM, I'm just going to let it run. And what we'll see is within 30 seconds, the cluster service will automatically restart, and it will then get access to the cluster shared volume again. It will come out of the isolated state and just go into an up state, and the VM should then just run just fine. So no interruption other than obviously the one that lost storage. So this is huge. So for those times where I don't have, so there's cluster service, see it's joining, it's up, VMs are now running, and that pause critical one will come back within about 20 seconds. That was weird. Oh, that was a weird blip. This is technical preview 4. Sometimes little weird things happen, but now it's running again. So you see, it's got that resiliency now from those failures. The other thing it does is if we were in this situation and a node keeps coming in and out, in and out, in and out of the cluster, I don't want that. I don't want this flapping node constantly making my cluster do weird things. So if a node ungracefully leaves the cluster 3 times within an hour, it gets kicked out. It says, you know what, you're not playing well with others, you go and sit over there. Any resources running on it are moved to other nodes. It's not allowed to play anymore. 2 hours later, when it's calmed down, it's sorted itself out, it's allowed to come back into the cluster. So it's again another feature to try and make these more resilient. Okay. Hyper-V. I'm a Hyper-V guy. I like Hyper-V. I could talk about this all day. Nested virtualization. I can now run VMs in VMs. Why did they do this? Hyper-V containers. Do you remember why I said there's 2 types of container, Windows Server container and a Hyper-V container? Well, I want to be able to run Hyper-V containers within virtual machines. So that's why that technology was added. Yes, I can use it for other stuff. Just generally, I can, maybe in a lab environment, I want to run Hyper-V servers within VMs. But I can now do nested virtualization. There's a new Hyper-V VMCX binary format. Prior to 2016, the configuration file was really just kind of like an XML file. I could edit it. I could corrupt it, which we did quite a lot. If there was a power cut, if something bad happened, the file could get corrupt, and I lose my configuration. This new binary format is resilient to that. If there's an unplanned power outage, if it's going to stay, I'm not going to lose my configuration of my virtual machine. It also means that I can't play with it anymore. So me as a user, I'm not going to get out Notepad and start editing my virtual machine configuration. I have to use PowerShell. I use the Hyper-V management tools. I use SCVMM. I use proper things. Production checkpoints. So checkpoints are this point-in-time view of a virtual machine. If I create a checkpoint, it creates a differencing disk for the virtual machine storage. It saves the memory to disk, the device state, and I can then resume back to that at any point. And we'd always say never use these in production. Very bad thing. Because it's not using VSS. Nothing's getting flushed out to disk. It's not aware that it's been shifted back in time. So if I take a checkpoint of a domain controller and then try to use that, hideous things happen. I get these bubbles of replication, I get duplicate SIDs, and nice things were done in 2012, VM Generation ID to help protect against that, but it still was a bad thing. Do not use checkpoints in production. Well, now they've called it production checkpoints, which is obviously going to say, well, I probably should use that in production. So what Microsoft have done is, if I actually go and look at virtual machines now, let's just pick this one, for example. I now have the option of turning on and using something called production checkpoints. So if I go and look at my checkpoints, you can see I'm using production. What does this do? This now calls the VSS infrastructure inside the VM. So it's basically like doing a backup. So now if I use production checkpoints, it's like performing a backup. It's going to call all the VSS writers inside the VM. It's going to flush stuff out to disk. It's going to quiesce any changes, and it's going to get a nice application consistent backup effectively of that virtual machine. So huge. You'll notice it won't bother dumping out the memory anymore. It doesn't need to. The disk is now application consistent. It's like a backup. So I have a choice. I can use production, or I can use the old style checkpoints. That's now just part of Hyper-V. Host Guardian Service, shielded VMs. These are technologies. I think there's two things here. It can use a TPM in the physical server, or I can use a Active Directory, acetation. Can't say that word very well. It's really designed to protect your VMs from your administrators. It sounds weird, but think of a public cloud. Hey, I want to make sure that Fabric Manager, they can't go and grab my VM and do stuff with it. So what these technologies do is, let's say I have this virtual machine, I can't take it from the host and run it somewhere else, it won't work. It's linked to that particular host. It's using maybe the TPM or Active Directory, you pick which one you want to use, and it's now using this Host Guardian service to enforce that protection. So even if I'm an administrator, I can't take that virtual machine now. I can't read it. I can't do anything with it beyond. So it gives me additional layers of protection for my virtual machines. There's virtual TPMs now. So I can have a TPM within my virtual machine. So I can do the cool stuff like the bit lockers, the other types of protection. Hot add remove of memory, network cards to generation 2 VMs. So a VM is up and running. This is different from dynamic memory, which would kind of inject memory but never truly remove it in the eyes of the guest. This is actually yanking memory out of the virtual machine. It has to be Windows 2016 or Windows 10, but I can now hot add and remove memory. I can add and remove network adapters. So while the OS is running, I can just add and remove these things. PowerShell Direct. You might say, well, what's this? I can now, from the host, directly interface with a virtual machine with PowerShell, even if networking's not working. So something really bad has happened to the VM. Networking's host can't get to it. PowerShell Direct is basically using the VM bus to talk to the virtual machine. It's not bypassing security. I still have to have a credential that works within that guest virtual machine. But basically, I can run invoke commands, and I do -VM name on the host, and it will send that PowerShell into that virtual machine through the VM bus. So even if every bit of networking and firewall is broken, I can still talk PowerShell to those virtual machines. Integration components now updated via Windows Update. No more worrying about when I'm on this version or that version. Am I running the right version of integration components? It's just going to work. I'm going to talk faster and faster now because I have 5 minutes left, and Steve's after me, and he's a big guy. Remote desktop services. RemoteFX now supports OpenGL 4.4. OpenCL is finally supported. RemoteFX support in Windows Server 2016 guests. So RemoteFX enables me to virtualize GPUs of the host and give a virtual GPU to virtual machines. That only worked with Windows client operating systems. Now it's going to work with guests running Windows Server 2016 as well. I can dedicate large amounts of video RAM to the virtual machines now using RemoteFX. I can use Generation 2 VMs for my VDI. I can now do personal session desktops. So this says, hey, user, rather than going to some random session host whenever you connect, you're always going to go to the same session host. It's a personal remote desktop session host. Pen remoting. If I have some flashy Surface device and I'm writing on my Surface device, that's going to now get remoted to my remote session. Now, you might say that works already. It doesn't. What's actually happening, those pen strokes you're doing are really mouse things. It's sending in these mouse activities. So it's not truly understanding the pen, it's treating it like a mouse movement. In 2016, it's now going to treat it and keep it like a pen. Multi-point becomes a key role, having these multiple users using the same machine. Console. Nice new features to the console. I'm going to speak faster and faster. I can make these things transparent now. So if I open up a console, So this is just a regular console. You notice it's a bit transparent? So I can now kind of see what's going on behind me. So that's one of the features. The other nice thing it does now is as I do a get process, it dynamically resizes. So as I start shrinking it, the word wrap does different stuff. So the console's been improved to make it far more friendly in terms of how I interact with that. Even quicker. Active Directory. Big thing here is we have too many administrator accounts. We don't protect them very well. We don't know who's using them. This is a new feature, Privileged Identity Management, that's going to work with Microsoft Identity Manager. You'll create a separate forest. There's a special new type of trust relationship. There's a new type of object that will have the same SID in this bastion, this second forest, as SIDs of secure identities in your primary domain. And that's now will get granted it as a time limit. So hey, I can get a new user in this bastion forest that's the same SID as my domain admin. It only lasts for 1 hour. So MIM will go through a workflow. Hey, I need to do an administrator activity. They don't exist in the primary forest anymore. It creates a new account for you over here with the same SID as domain admin in your primary. There's an update to the type of trust, so it will pass that SID through. I get this account. The Kerberos ticket will only last for the lifetime of this 1 hour or 2 hours. So I can do administrator stuff for an hour, and I lose those permissions. So this is kind of like some of the Azure AD privileged access management we're seeing, but I now have these very controlled ways to have administrator credentials with these privileged accounts. This is a way I can finally lock these things down. And lastly, I have 2 minutes, Azure Stack. So this isn't a Windows Server 2016 feature, but I think this is going to be huge. This is not WAP v2. It's not Windows Azure Pack v2 that looks like Azure but isn't Azure. Azure Stack is Azure. Azure Stack is the binaries from Azure running on premises. They're going to run on Windows Server 2016. It's going to run on Nano Server. It will have some of the PaaS services, the IaaS, the storage. It will have consistency with Azure. So hey, I create a template that runs in Azure. It will run on premises as well. I'll have easy migration between them. So if I'm looking at hybrid cloud, if I'm looking at kind of a true fabric, Azure Stack is going to give you that. It's complete cloud consistency with Azure. Now, it doesn't mean every feature of Azure will be available in Azure Stack. Some things don't make sense. Machine learning, where there's tens of thousands of compute nodes, probably doesn't make sense to run on premises. That probably will not be there, at least initially. But things like your basic IaaS, VMs, platform as a service, storage, you're going to have that. So it's going to be consistent with what you have in Azure.